I'm Leif Wickland. I work for the RootCon project. We have an office in town with a few people in it. You may have heard Frederick's talk earlier. He's also there with me and some other folks. Before that, I was one of the right now people that got acquired by Oracle, and I did my time there. Been in Bozeman for 18 years, I think. Yeah, about that long. So I've done a wide range of things in my life, from software for livestock auction yards to big data systems that process trillions of things a day. So I've done some user interface. I'm not very good at that, but lately I've been doing lots of backend stuff. This talk was inspired by a blog post I saw from a guy named Leif Wickland. Pretty sure I'm saying his name right. It's an Asian name, so the first name is the last name, surname. So I'm going to call him Howie from now on. He wrote this blog post that I really like, and I've tried to take inspiration from it and not steal it outright. If I'm saying things that are dumb here, blame me, not him, but I think he deserves credit for at least pointing me down this route. So when he wrote that post, it was originally about a particular way to write the Scala programming language. But I think there are a lot of good lessons in there. I'm going to try to talk about that today. So if you read the word salad, that was the title of my talk. You may have seen strategic power in there. Like the 1960s idea of I got more missiles than you do. So that's not what I'm talking about. That was not the order. We're talking about Howie's principle of least power, which is given a choice of solutions, pick the least powerful solution capable of solving your problem. And that would generally make me as a developer uncomfortable, because I like to make powerful, flexible things so that I feel like I've just really robustly solved a problem. Or maybe I'm not sure where we're going to go with the product, so I need to be flexible. So I give it all kinds of ability to change. Or I may not even know what the product manager is going to do to me, right, Jeff? So maybe I just have to build it in such a way that I can do whatever I'm going to have to be expected to do next week. But when we choose designs that use really powerful things, it means that we or whoever comes after us have to understand all those possibilities, because it's sort of hard to assure somebody that you're not going to use that full power. So if the software can do anything, it really might do anything, which means there's a greater range of possibilities to consider. So here's our motivation for this talk. A restricted solution that can only do a few things, straightforward for somebody to inspect, analyze, and manipulate later. That's coming from Howie. So this is why I'm trying to do this. So let's move on here. I'm going to use a bunch of words, and I'm probably going to use them inconsistently through this talk, just because that's the way we normally think about this. So if you hear the word power in relation to software, you normally think that's great. It's a good thing. But the way I'm trying to use power in this context is that it is something that has the capability to do many things. I'm going to use the word restriction. And normally we feel like restrictions are bad, like there's a dress code at work, I have to wear shoes. That's not cool. My tootsies need airing out. But I'm going to try to use restriction in a different way, where we say that the restrictions enable us to reason about things more clearly. I'm going to use the word possibility. And again, possibility sounds awesome. Graduation speakers talk about all of the great possibilities you have in front of you. When I'm looking at your code, I don't want there to be lots of possibilities. I want there to be a small number of possibilities so I can figure out what you were actually trying to do, and here's what you actually did, because you probably didn't do what you meant to, or else I wouldn't be looking at your code, because there's probably a bug there, and that's why it's wrong. Or my own code, let's be honest. Constraint. Again, constraints, we're not comfortable with constraints. We don't like constraints. They feel bad. I can only spend $30 on lunch when the company's buying, that sort of thing. Right? I can't hardly get my fine 18-year scotch into my constrained $30 budget. It's no good. So by way of metaphor, I'm planning for a trip in a couple of weeks. We're going to go to Australia, we're going to go to New Zealand, we're going to go to Fiji. And I'm hoping, since it'll be winter, I'm going to ski in New Zealand. And since it's Fiji, I'm going to sit on a beach And because it's Australia, I'm hoping to go snorkeling at the very early. So you can imagine that that's a lot of stuff to pack. I gotta fit all kinds of things in there, and it would be really easy to do all of this. And this is a powerful pile of luggage, right? There are very few constraints on what I could carry along there. But because of that, it's got a lot more stuff to take. It presents its own set of problems, right? When my wife and I went to Europe 2 years ago, we went to 5 countries in 12 days. And we lived out of one of these. And that was really liberating. We were able to not worry about, did our luggage make it with us on the flight? We didn't have to worry about, can we get a taxi to get us from here to there? Because, I just stuck the backpack on my back and we walked where we wanted to go. If I'd had that massive pile of luggage, I would have been much more limited in what I could choose to do. So, since I was willing to accept a constraint on how I was packing up front, when I went to actually use my luggage, I was much freer. So that's kind of my metaphor for where we're trying to go with this. All right, so like I said, originally Howie wrote his blog post about Scala, and I am going to, in the spirit of an essay, try to apply that idea somewhere else. And you are my lucky guinea pigs that will get to tell me I'm wrong, and that this does not apply to your favorite language. I have tried to pick a wide variety of languages that I can ridicule with bits of code in here. If I didn't pick on yours, it's because I don't like it enough to pick on it. Go, for example. But, PHP gets some love. I try to pick on most everybody. So, we'll try to go there. What I'm not talking about is picking a language, or picking a framework, or picking a library. I'm trying to talk at a very low level. As you're writing code every day, how can you choose to make slightly less powerful decisions that will help you make more maintainable software somebody else can get to more easily? Okay, hopefully that's enough exposition. You see where I'm going. Let's get to some code. Let's get some nice examples, and let's pick low-hanging fruit that we can get to right away. So here is an example from the Microsoft documentation on GoTo. What happens if you pass this mess, the number 3? Anyway. This is C#, a modern choice.
Case 1 break 75.
Happy birthday. Right, it increases cost by 75 when we pass in 3. And all of you spent, 45 seconds looking at this and, thinking hard, is that really what it does? Because I can't tell. GoTo is super powerful, right? It can do, arbitrary random things, which is hard to understand, right? We generally, as an industry, since, 50 years ago, have said GoTo is a bad idea. Our dear saintly Dijkstra wrote an essay saying this is a bad idea. And generally it is. So in my talk description, I promised you I was going to tell you about new language features, right? This isn't new. This is a thing that we've known was bad for 50 years. Right? I mean, what? All right, okay. So, languages that have come more recently haven't done GoTo. So Java, for example, doesn't have GoTo. And occasionally at work, I get to look at some code that's written in Java. This is sort of a notional view of some code at work. Can anybody tell me what this is trying to do?
Trying to make a valid BAS from a bunch of user input.
Yeah, why is this in a while loop?
Taking raw input.
Oh, but how many times can it possibly go through the loop?
Until it breaks.
Right, this is just a very clever way of writing GoTo without the keyword. And it made me cry a little, and then it made me shout a little. But, you can see, after you spend a while, what he's trying to do here. And he's picked, a really powerful abstraction. He's picked while, which is a thing that can go on for a long time. And then you just pick break, which can make your program go to another place without returning a value or doing anything in a particularly structured way. And he's doing it in a misleading way, right? I mean, if I were going to try to make this better, I might do something like this, where there are really two clear paths through here. I'm calculating three things up front. I check if they're all valid, and if they are, I make a thing. I don't think this is the best possible way to do this, and I'll come back to this later. But I'm just trying to convey this idea that powerful, we normally think of as great, isn't necessarily always, and doesn't necessarily lead to maintainable code. He was able to write something very simple that felt easy to him by doing this, right? Because he didn't have to think through what the steps were and kind of divide them out. But I think we ended up with something that's easier if we do something like this. We constrained our complexity. There's this idea of cyclomatic complexity. We go back to the other thing and measure it. We get a number like 7. If we look at the thing I replaced it with, we get a number like 2. And lower is better. Golf scores for cyclomatic complexity. Hooray. So there's one example. Let's go to like another area where we can talk about how we can constrain the power of what we're doing. So most languages have some way to indicate that a value can't change. We might call it constant. We might use the word final in Java. Right? There are various ways to indicate this. And I think that idea of immutability is very, I want to say powerful, but I don't mean that. I mean the opposite of that. I mean it's very restrictive, and it helps the reader of the code understand what you're trying to do. He doesn't have to reason about so many possibilities. I don't have to understand that this thing can change after you've given it a name. Okay? So, for example, I hope you can read this in the back, and I've made it large enough. If you can't, feel free to come forward. Here's a sample of code. My friend Bob sometimes has bad days, and when he does, he feels bitter. So when we're going to try to describe how Bob's day is going, if he's having a good day, we'll say he's okay, and otherwise he's bitter, right? I mean, this I think probably looks like code you see often in JavaScript. Like, how could we do that in a way that wouldn't require us to mutate state? JavaScript in most modern places has a const keyword now. And we can just say Bob is either having a good day, and he's good in that case, or otherwise he's bitter. I don't love the ternary operator, but it lets me express what I want, and just one time set the value of label, and then the reader doesn't have to wonder what other values it might have. The interpreter is going to ensure that he didn't go off and change it some other way. I was pleased when I started working on this presentation to discover that the const keyword is really broadly supported in JavaScript now. The nice folks at caniuse.com estimate that 94% of users on the web have a browser that supports this. If you're trying to use the other newer hot way to declare variables in JavaScript, they estimate only 60% of people on the web have that. So, today in JavaScript, you can go off and do this. I think that's a good thing. Let's say we want a slightly more complex example here. We want Bob to tell us about his feelings. Right? By default, Bob's kind of in a meh mood. And when he's having a good day, he's feeling very hot. But otherwise, we might go back to that bitter case. And again, I think this looks a lot like what you usually see in JavaScript. Like, how could we get rid of the mutability here, right? We've got that var, and we change its value as we walk through this. How could we avoid that? Let's say we don't have that const keyword. Well, I think we could do something like this, where we say, if he's having a good day, like literally just immediately stop what we're doing in this function and say he's hot, right? And so forth. Does that kind of make sense? Like, we've managed to eliminate mutability without having to have access to that fancy const keyword. So, in general, Howie's suggestion is, as far as possible, avoid immutability. Prefer immutability. There are definitely cases where immutability leads you to worse performance. There really aren't that many that are crucial because there are very few hotspots in your code where it matters. So in general, I'd say prefer immutability. If you do have to use mutability, you can generally bound it very tightly so that you're not taking in mutable data and you're not returning mutable data. And you've just got this kind of function or module in your code that does that sort of thing. And everything outside of it can live on happily. And you've noticed I've only talked about part of the picture of immutability. Can you kind of think of what the other side of this would be? I'm only talking here about the local variables, the names that you give to things. We've also got the other side of it where the objects and the collections that we make can be immutable, right? Our typical sense is I've got a user and I need to assign them a new phone number. Well, I'll just set the phone number on the user, right? And now my user has the right phone number. But that's the idea. My user is mutable. Or my user has a list of phone numbers, and I'm just going to add another one into it. Or say I've got some best friends, right? And my best friends are friends forever. Except the typical way we do this is that line there at the top, right? We say that we've got a list of friends, and we're going to put that into the name of our best friends. But that has two possibilities. The list itself can change, and we can change names to point at an entirely different list. So here, maybe on the second line, I'm in 4th grade, right? And I've written in my scrapbook, these are my best friends. And as it turns out, like my list lets me scratch out their names as I'm going through. Or here I am in 5th grade, and I've decided I'm much more mature, and so I'm never going to change this page, but instead I'll just replace it with a whole new page when somebody treats me bad, right? Or, you know, here's our last option where we don't change anything at all. So Howie's suggestion is don't use double mutability. That top line is not the one we want. Like either, if you're going to have mutability, let your name change but not the objects, or let the objects change but not the name, or, you know, if possible, we want to take this last choice. Okay, shifting gears again. What is the simplest interface to a module that we could think of? Like you're writing some new functionality in your code base. You know that it's going to be used from somewhere else. You are going to have to define some sort of boundary for where those two things talk together, right? What is the least powerful, the simplest interface that we could define in between those two? So to make this more concrete, like let's say we're going to make a library that defines cycles between nodes in a graph. Now, I'm not going to ask you to write that algorithm. I'm just saying, if you were going to write that, what would it look like?
Function.
Well, I'm not asking about the implementation. Like, we're going to go back to our CS textbook, and it's going to tell us how to write this. But that doesn't tell us that what's a useful way to expose that functionality, right, to somebody within our code base. What is that boundary? What should that look like? Go ahead.
Just takes in a graph and returns a list of the cycles.
So how does my, what is a graph in that case? Like, how can I write my code to take a graph?
Set of nodes.
Set of nodes, okay. So we've got nodes, and we talked about a graph, it sounds like. So we've got a node, and let's just give our nodes names. We've got a graph, and we can add edges to our nodes by connecting two nodes together. And then we've got a function that we can call on our graph at that point that'll tell us if we have a cycle in there somewhere. I found this by Googling around, and like this was the third result, roughly. I tried to simplify the interface a little bit so it fits on a slide nicer. But you know, this is a common way that I think people would do this, right? So the downsides here are that if I want to use your stuff, I have to create a node, a graph, and I have to create nodes. I can only use it with those data types that you've defined. And because you defined your node to take a string for its name, it can't stash any other information for me. So I don't know, like that kind of constrains what I, as the library user, can do. I mean, you got lots of power as the author, but I don't get to make the choices now. And there's only one way that I can define the connections between my graph. I have to use this add edge method. Maybe that's not convenient for the way that my data is defined. So how can we make that better? Well, like a typical way that we would think to do this, most of us have been brought up in like an object-oriented sort of programming, then whoever comes along after and wants to use our library, they'll just make their derived much better node, and they'll put whatever data they want into it. And then we'll make the graph abstract, and then they can connect things however they want. So maybe that would look more like this, where we just require that the node have some sort of name, and then when they go to get a graph, they just have to tell us what the nodes are and tell us what each node connects to. They give us back, when we tell them as the author of the library a node, they tell us which nodes that connects to. And then we'll implement the has cycle so that they can call that. I don't think that's the best solution either, but I think that's really a familiar feeling approach that we would see in object-oriented background design, right? There's a thing, a class for each thing, and we kind of can map those concepts in our head. So all right, let's hurry along just a little bit here. So how can we reduce the setup, so we don't make the user to derive classes from each of those things? How can we help them avoid instantiating stuff they don't want to? Well, what if we had a static function, right? And we don't make it dependent on a node type that we've defined. We just will take any consistent type, any n, and then instead of making the user tell us as the library author all the connections, we just let them tell us when here's a node, here's what it connects to. You see how these are all sort of similar solutions, but now we've restricted what we as the authors of this library can know about the data that we're receiving. So, I mean, does that make sense? Do you kind of see where I was going with that? Right? So Howey suggests that the simplest way that you can expose functionality is with a static function that has standard types, the types that your language just includes with it, strings and integers and other lovely things like that. If that won't work for you, then we could introduce some custom types, right? If you need even more power as the author, not as the user of the library, but as the author of the library, then you could make the user instantiate some class. Right? I mean, then they have to understand probably something more about your library in order to be able to use it. And then finally, there's this subclassing, right? That you have defined some abstract thing. They have to go subclass from that and then hand you probably an instance of that. A bunch of our languages now have closures. Changing gears here. Now that Java added them, almost every language had them, since Java is the least advanced of the major languages these days. We use the term lambda or closure kind of interchangeably. Does anybody know what the technical difference is between lambda and closure? Ryan's scowling at me. Feel the hate. Okay, I'll attempt to explain this. Lambda is an anonymous function. It's like this thing that is just hanging out that doesn't have a name, and it can be passed around like a value. A closure is a lambda that can grab onto values outside of it and carry it along with it. So as you pass along a closure, it's holding on to values that it saw in its neighborhood, so that you don't have to include that all in there. Now you'd think you could use those terms interchangeably, but at the point that PHP introduced lambdas, they didn't actually make them closures, which turned out to really reduce their utility, so they came along later and fixed that. So there's a distinction. I'll probably generally use the term closure, but lambda is a much more visual concept because it's got the beautiful Greek letter to go along with it. We often think of closures in contrast to classes, or functional programming as opposed to object-oriented programming. But I don't know that there's really that much of a dichotomy there. Both closures and classes are able to wrap up around state. Just talked about this, that I can write my anonymous function and it can see a value that's sitting outside of it and grab onto it and go along with it. Kind of like when I create a class, I can pass it an argument and it can hang on to that thing and it can become a member variable in the class. And we call that encapsulation when we're talking about a class, but you get the same effect with the closure. The closure has one method that can be invoked. The class can have one or more, right? You can think of a closure constructor as a function that takes some arguments, and it returns a closure, and the closure has grabbed on to those variables that were the arguments, and now I've sort of constructed a closure with a particular set of state. Sure, a closure only has one method, but you can imagine that you could fake more than one on a closure if you wanted to be really evil, where you pass in a string as the first argument to your closure's method, and then you switch inside your closure to make it go do something else, right? I mean, I really hope you don't ever do that. I just like to occasionally suggest bad ideas to see what people do with them. So typically, we'll write functions that take some sort of class or some sort of object, however you want to describe that thing, right? Even if the function only needs to call one method on that class, on that object, we'll pass the whole thing in there a lot of times because it's just easier. I don't have to, as the author of that function, think about what I need from that thing. And I think that gives the function too much power a lot of times. So it can access methods it doesn't need. It can produce tighter coupling than we really we would want, I should say. Right? And that tight coupling leads to brittleness. When we go to refactor later, we find that our function has gotten really tightly nested with that thing we passed to it. And it, like more scarily, if we didn't make our object immutable, the function might be changing something totally unrelated to what we thought it was doing with it. So instead, what if we passed a closure instead of that class? The closure is a whole lot more restricted, right? It only has one place we can interact with it. The closure is a function, so we can just call the function itself. It gives us an abstraction layer, right? Normally, if you were brought up in object-oriented design like I was, if I want sort of this abstraction layer between 2 points, I define an interface, like, keyword interface, and I say it's got this method. And that's painful. That's a lot of code to write to just buy myself a little abstraction. If I want that same level of abstraction without having to go through so much boilerplate, I can just say this function takes another function. And at the point that I call it, hopefully your language gives you enough syntax sugar. It's not painful to define that anonymous function there that satisfies that interface. And we've decoupled stuff. We don't need to use inheritance for this, right? Inheritance, I think, probably deserves a bad name for making code brittle and tightly coupled. And I think we overuse it. And I think we can do this sort of thing to allow us to have those common interfaces, that abstraction layer, without resorting to inheritance. Now, if you're coming from like more of a JavaScript background, you're thinking to yourself, everything is a function, because basically in Java it all is a function, and you're just hiding. So how does this apply, right? Well, I mean, when you pass that function into another function in JavaScript, you can happily go off and access other things. That's true. So you can write an anonymous function, you can write that lambda, that closure around the thing you're passing in to prevent that from happening. Kind of to back up this point, there was this lovely blog post I saw. Adrian Collier is a venture capitalist that, oddly enough, reviews a bunch of theoretical CS papers, and he does a really great job with it. He's got a blog where he talks about something, and this morning, or yesterday morning, I can't remember now, his paper was about architectural hotspot patterns. And this team had gone off and analyzed a bunch of, I think, 12 projects. And they found the spots that had lots of bugs, and they identified these 5 areas. I think we can address a bunch of these by decoupling them, by using this pattern of trying to pass a closure instead of an object, and a lot more of it. I certainly think you can overuse it, right? There are limitations to this pattern of passing a closure, because at the point that I have some function that takes 3 closures, yeah, maybe I should have just defined an interface to like group those methods together. I'm not going to say I haven't shipped code where I took 3 anonymous functions as my argument, but I maybe should have considered a new interface. I didn't, but yeah, there it is. So like coming back around to our example, like here's sort of where we started. And here's what I'm saying I think would be sort of the simpler way to solve that. And when we go to call this thing, assuming that we ended up as the users of our graph library, defining a node that looked roughly like that, when we went to call hasCycle, we'd be able to call it like this in Java. Right? It doesn't feel like it's that much more painful to me. But we've reduced the coupling between our library and whoever is using it, and we've given them a lot more flexibility to implement things however they choose. Have you heard of the term koan? It comes from Zen Buddhism. I am only passingly familiar with the term. It's typically a parable-like story that expresses some degree of paradox to help the listener come to enlightenment. Which, to my ears, doesn't make a whole lot of sense, but it's kind of fun to play with. So I happened to stumble across the following that was on the MIT mailing list 15 years ago or so. A guy named Anton Van Straten wrote this following thing up, and I thought it was cute, and hopefully it helps illustrate what I was just talking about. So the venerable master was walking with his student Anton. Hoping to prompt the master into a discussion, Anton said, "Master, I have heard that objects are a very good thing. Is this true?" The master looked pityingly at his student and replied, "Foolish pupil, objects are merely a poor man's closures." Chastened, the student took his leave from the master and returned to his cell, intent on studying closures. He carefully read the entire Lambda the Ultimate series of papers and its cousins, and implemented a small scheme interpreter with a closure-based object system. He learned much, and looked forward to informing the master of his progress. On his next walk with the master, Anton attempted to impress his master by saying, "I have studied diligently, and now I understand that objects are truly a poor man's closures." The master responded by hitting Anton with a stick, saying, "When will you learn? Closures are a poor man's objects." Anton then became enlightened. Right? I mean, I feel like I've yanked you back around, but I think the point is legitimate, that we can use closures in some of the places that we use objects, and it'll help us decouple our designs. So another new feature that some of our languages have gotten recently is the option data type. Java calls it optional, other places call it maybe. If it's not in the standard library, there's almost certainly somebody on GitHub that has made this because it's typically only a few lines of code. In general, I think option provides us a really nice way of handling errors. It allows you to indicate that there is a value present or that something failed. You don't end up with confusion like old school C, where you're returning error codes, or new school Go, where you're returning error codes that might mean something. Right? Is that one a failure code, or is it indicative of something? Or PHP, right? You would ask PHP back in the day, is this character present in this string? And it would tell you 0, yes, it's the beginning, or false. And if you said that value equals 0, well then, yes, that means both. I didn't find it and I found it at the beginning, because PHP is awesome like that. Sorry. All right, I only feel sad about PHP because I had to use it. So, it still burns deep in my soul. All right, right, option like that code that I looked at originally lets us short circuit past errors. Once we see an error, we don't keep processing. And I think that option really comes into its own, or these other types like that, where you can pair it with functional programming techniques like lambdas. So I'm going to try to show you this in Scala because the demo is a lot nicer in Scala. And then I'll show you what it looks like somewhere else, just so that you can realize the inherent beauty of Scala. I mean, so that you can apply it to what you do. So in Scala, there's a type called option, which is exactly either a sum of some value or none. Right? If I went to validate something, I could say, yep, that's cool, here's your thing, and I'd wrap it up in a sum, or nope, I'd give you a none back. And then there's this lovely syntax sugar, a for, that lets me do something like, if I have a sum of 5 and a sum of 7, then evaluation will come all the way to yield. It will do the math on the values that I've taken out of those wrappers and return the newly wrapped up value. And if one of those values is bad, like our y here is a none, then we get to here, we bail out, we don't do this multiplication, and you get a none. So we go back to this glorious piece of code. We think, how could I apply option to this situation? Right? Well, I mean, the first thing we can do is we can stop trying to inline define all those things. That's just good software design, right? We shouldn't write functions that are 100 lines long because very few of us are smart enough to actually understand 100 lines of code put together. What else can we do to make it better? We can stop creating objects that are in an invalid state, right? He made himself a foo, and he changed it, and he changed it, and he changed it, and then he checked if it was good. Well, what if we didn't do that? What if we didn't create a foo until we knew it was cool? Or if, we did have to mutate it for performance reasons, we didn't let that mutation escape a function until we knew we had a good one. And then we could hand it to the user, and then they could use it knowing it was good, right? And we can use option there to tell us, to help us convey back to the user that the thing is good. So here's my attempt at Scala writing, that sort of thing, right? We've got a function that makes a foo and a bar and a wah, and they all return optionals of those things. They're using our glorious sugar syntax here that makes it so delightful, where if at any point one of these returns a none, we'll just skip out, and there is a none being returned. And if we're good all the way through, we'll create a baz for these things, right? It'll get wrapped up in a sum, and whoever comes after us will either have a sum baz or a none. That feels pretty good. All right, now let's look at it in Java. This won't feel so good. Similarly, we've got our functions, and that looks about the same, right? But we don't have that syntax sugar, so it's going to look more like this. I'm sorry. I still think it's a good idea. It's not pretty, but it's still a really powerful thing where flat map means I want you to take the value in here, and if it's sum, take the value out, give it to me here. I'm going to go do something where I'll give you back a new sum or none. And I can keep walking down and doing this. And at the point that I do a map, that means if there was a sum here, then I'm going to give you a new value, and you're going to wrap that up in a sum. And they all just get returned back out. So I think option is entirely useful because it helps us avoid common pitfalls. Like Cole said earlier, we're not supposed to use throwing for flow control. It's not that exceptions themselves are inherently bad. Cole kept talking about exceptions like they're bad. Exceptions are cool, man. They tell you where your error happened and why they happened. It's that we then throw that exception, saying, I am entirely willing to end my process if no one catches this. And then we go and use that for flow control, and sadness results, right? The throwing is like this painful thing. Well, this helps us deal with failure in a way that's safer. We don't deal with null then, right? Null, literally the guy that invented null 50 years ago goes around and gives this great presentation about why null is $1 billion mistake. I love it. Not null, the presentation. I hate null. And we don't have to check the error code, right? The old school C style or the Go style is that you get back this error code and you have to check it before you go read this other value. And if you forget to check that value, then you've got an invalid thing. And that sucks, right? I mean, the nice thing there about this is that bar never was exposed to the constructor here if there wasn't one. Right? In our Java version, we never entered this lambda if there wasn't a bar. That seems better. So option has its limitations, right? It only allows us to say there is a good thing or there isn't. If you need something more powerful than that, there are other types like either that can help you express that. So here I am at 80 slides in my presentation. I've got 5 minutes left. Let's try to put a bow on it. So I think if we deliberately put constraints on ourselves when we're writing code, that can help us write simpler code. It can help us write more maintainable code. If I, as the person reading your code, or the code that I wrote 3 weeks ago that I don't remember at all, have more predictability about what it's going to do, hopefully you're the first person that uses your code, because you're not going to just write the code. You're going to go call it from your unit test, right? We always do that, right? And then the more powerful solution isn't always the better one, right? Or more cheekily, mo power, mo problems. All right, so how are we going to do that? We're going to use immutability. We're going to write ourselves constrained interfaces, right? Like the static function that takes built-in types is the most constrained, the least powerful thing we can do. We can use lambdas to help us have a reduction in coupling, and we can use option to express possible failure. If you would like the slides that I just presented, they're on my Twitter account, which is that guy. I already posted a tweet there with that. And if you have any other questions, I'd be happy for a few minutes to listen to them. Okay, go ahead.
Yeah, I have a question. So I have a question about a pattern around immutability. I do a lot of JavaScript programming, which is things are always changing. That's just inherent in the language that took 10 days to invent.
Thank you, Mr. Ike.
So if I have some object and I want to transform that object into something else, so I call a function to do some transformation. So should I do a deep copy of that and return a new object instead of changing my existing object and passing it into this function?
Yeah, that's a real hard sale, I think, because if you don't have some sort of syntax or help from a library and making it easy to do those deep copies, writing a deep copy manually is incredibly painful. If your object had 4 members, then you would have to make a new JSON literal in place and copy 3 of them in and then set a new value for the 4th. That sounds painful. Given that you might not have that, I would say maybe consider putting that into a separate function, or maybe you have libraries like the Java ecosystem that make that better, JavaScript ecosystem. I don't know. I happily haven't written JavaScript in a few years, so I don't know. But I would consider, can you at least constrain all the ways that thing has to change into some function so that I know going in and coming out kind of the bounds on what I can expect as behavior.
There are JavaScript libraries that will give you data types that use structural sharing, so it doesn't actually do deep copying, like Mori, M-O-R-I, one of them.
Check that. Thank you.
Yeah, when you're talking about data structures or collections and you want persistence, not persistence, immutability, the typical, another term to look for there is persistence or structural sharing. There's really nice academic research from 20-some years ago about how to build collections that are efficient, that are immutable. And I mean, I was in college nope, not quite. I was almost in college 20 years ago, and I didn't hear anything about it when I was there. So oddly enough, it hasn't diffused that far through our community. Like, Google publishes a collections library for Java, and it doesn't use any of those techniques. And as a result, the performance is so much sadder than it should be. Well, thanks for coming.